Everyone hearing? Fine? Yeah? Good? Yes, so my mentor was James Edward.
James Edward, great.
Yeah.
All right.
So I'm going to be talking about Geocode R, which is constraint programming in Ruby. So the first question is, of course, what is constraint programming? Is there anyone here who has heard of constraint programming before? Anyone at all? Okay. So constraint programming, well, what is it? Well, basically, Sudoku is constraint programming. Is there anyone here who has not heard of Sudoku or does not know what Sudoku is? Okay, so as you all apparently know, Sudoku is a puzzle where you have a 9 times 9 matrix of squares, and you have to assign a value to each square so that a value in range 1 to 9 to each square, so that some constraints hold, namely that in each row you can only assign a specific value 1, so the squares in a single row have to be different. And same thing for columns and these kind of subregions, these 3 times 3 blocks. And this is basically a constraint programming problem, because a constraint programming problem consists of 3 parts. First, the variables, which in this case are squares, and then domains, which in this situation is 1 to 9, since you can only assign a value in range 1 to 9 to each square, and then you have several constraints, which in this case is that you must have distinct values in the row, column, and region. So Sudoku is a constraint programming problem in the sense that it can be expressed in this way with just variables, domains, and constraints. And an important point of constraint programming is that it's declarative. So all you do when you use constraint programming is to kind of define the problem or give the problem in some sense. And then you hand the problem over to a solver, which then solves the problem. And in the case of Sudoku, you would describe the problem of Sudoku by giving the variables, the domain, and the constraints, seen in the last slide. Then just hand it over to a constraint solver, which in this case is done with Geocode R. So just like, for instance, SQL or SQL, I'm assuming here that everyone here has used a database with SQL or SQL or whatever you want to call it. In SQL, you just give a query. You say that, oh, I want all values in rows where this thing holds, and I want to join the tables and so on. So you don't actually tell the database how it should do that. Just tell it what kind of result you want. And it's the same thing with constraint programming. Just tell it what kind of problem you want it to solve, and then you tell it to solve it. You don't tell it how to solve it. That's important. And why do we do this? Well, in the case of databases, we do it because, well, not everyone can be an expert on relational algebra or whatever is used. And if you're not an expert on relational algebra, I'm not sure if that's the correct name in English, but anyway, if you're not an expert on that, then you can't be expected to optimize a query. Because, and in SQL, that's actually done by the database, so you don't have to worry about it. The database makes sure that it looks up the rows in the correct order in the table, so that and filters rows so that you don't have to push around a whole lot of memory. And the database does this automatically. You don't have to tell it to do that, but it's thanks to that you only state a problem. You don't try to tell the database how to solve the problem. And it's the same thing with constraint programming. So you only state a problem, not how to solve it. And in the case of databases, you hope that the database will do something smart. And it's the same thing with constraint programming. You hope that the constraint solver will do something smart, so you don't have to worry about it. So now that we know what constraint programming is, what is Geocode R? Well, Geocode R is basically a Ruby interface to a library called Geocode. And Geocode is a C++ library, a constraint programming library written in C++. And what this means is that Geocode R basically it kind of gives you the interface to describe your problems, and then the problems are sent on to Geocode. So I've only written Geocode R here. I've not written Geocode. I'm not involved in Geocode. So basically, Geocode R gives you access to this constraint programming library in Ruby. So you can describe your problems in Ruby, which is very nice since you can make very readable definitions of the problems in Ruby, and then you hand it over to this C++ library, which actually solves it for you. You don't have to specify how it should solve it, it just does it, and it does it in a smart way. Hopefully, a smart way. So now we might want to solve. I'm actually going to skip this part because we're out of time, or we're short on time. But for instance, if you would do this for Sudoku, or I should show it anyway, then you would have to. There are several. So basically, if you would do this in Ruby, then for Sudoku, then you would write a program that basically says that, oh, a Sudoku has in a Sudoku the variables are squares, and they can each be assigned values between 1 and 9. And in a valid assignment or a valid solution for a Sudoku, there are some constraints that must hold. And that's basically what you write in your Ruby code, and then you just send it on to the solver, which then finds a solution which satisfies all the constraints. So what can we use constraint programming for? Well, typically, constraint programming is used for combinatorial optimization problems. So, for example, scheduling. You might want to, for instance, build a bridge, and you need to schedule certain tasks so that they are executed in the correct order, and you might have some resource limits. For instance, you might only have 3 trucks, and one truck is needed when you dig a hole for a bridge and whatever. So you can't have multiple tasks using up too many resources because you have limited resources. So you have many constraints. You both have constraints on the order and both have constraints on the resources. So, for instance, that's an area where constraint programming is often used. And also, since it's declarative, it's very useful for problems which you can describe easier, or where problems which are easy to describe, but somewhat harder to construct an algorithm for solving. For instance, the most recent thing I used constraint programming for was to solve, or was an automated Minesweep player. I assume here everyone knows the game Minesweeper. So basically the problem of finding, for instance, squares, or deducing which squares are not mines is, well, it's non-trivial to implement such an algorithm which kind of finds all the corner cases, etc. So you can do that in constraint programming, since you can describe Minesweeper in a rather easy way, or you can describe Minesweeper as a minefield where each square can either be a mine or a value between 0 and 8. And if it's a value between 0 and 8, then it must be that number of mines in the adjacent squares. So that's the whole definition of the problem, and that's all you need to input into Ruby, and then it will, given your current information about the minefield, it will deduce additional information that it can deduce. So at the moment, Geocode R supports most of those things in Geocode that are related to modeling, so it's rather complete in that sense. But there are still many ideas left to implement. There's lots in the development mailing list. All this project, by the way, posted on RubyForge, where you can see the mailing lists and so on. And those ideas are things like more syntactic sugar, so that you don't have to have too many variables or too many variables. Simply making it easier to define the problems, and basically there are many such ideas left to implement. And feedback is very welcome, because the web page here, I showed the URL in the first slide, is meant for people with no experience at all of constraint programming, and tries to kind of introduce people to constraint programming. But I'm unsure whether it's on a good level. So please, if you read it and can't understand it, then please send a mail on the mailing list, and describe what's hard to understand, and I will try to fix it. So that's basically it. Any questions?
Could you just show us just the code, like a very short example? You don't even need to go through it, just so you can see what an example would be like.
I'll see if I can scroll this. Nope. Let's see. So basically for a Sudoku, each problem is defined as basically for each problem you create a so-called model of the problem. And each model at the moment is a separate class. So you inherit from this Geocode model class, and then for instance in the constructor or wherever you want to have it, you define your variables, which in this case is in Sudoku we had a matrix of squares, and you can see each square as an integer variable, something which you can assign an integer to, basically. So in this case, we say that size here is 9. So we say that we want an integer variable matrix of size 9 times 9, and we say that to each variable we can assign a value between 1 and 9, so that's our domain. And then we basically just add the constraints here. For instance, that the rows must be distinct, so all the variables in all the rows must be distinct. That's basically it. And then we had the initial set values too.